In today's video, we'll be going through Rolle's theorem. Well, Rolle's theorem has three main criteria. Those include that f must be continuous on the closed interval a comma b, f must be differentiable on open interval a comma b, and it states that if f of a equals f of b, then there's at least one number c that f prime of c equals 0. Now let's go ahead and do the practice problems. Well, our first practice problem says to determine if Rolle's theorem applies, and it says that f of x equals x squared minus 2x over x plus 2 on the closed interval -1 comma 6. So the first thing, and again we can refer back to our criteria, is that f must be continuous on the closed interval a comma b. Well, are there any values that would make our denominator equal 0 on this interval? Because remember, if a fraction is there, if we set the denominator equal to 0, it does not exist, or it's undefined, and it would not be continuous at that point. So the only value that I can think of that would make this denominator equal to 0 is -2. So now we have to ask ourselves, is -2 in between -1 and 6? Obviously the answer is no. So we can assume that this function is continuous. So we're going to write that out. So f of x is continuous on the closed interval, and we're just going to write brackets, continuous on the interval -1 comma 6. So that is the first step done. Now let's go ahead and go to the second criteria. Second criteria states that f must be differentiable on a comma b and open, so it's an open interval a comma b. So we can go down and we can see that for it to be differentiable, it must be continuous, and we must be able to take the derivative at any point. There must be no corners or cusps, and that will be in a future video explaining how to determine if a function can be differentiable. So here we can say that it is differentiable because there are no places where a corner or cusp appears, and it is continuous as we stated in the first part. So we're going to say f of x is differentiable on the open interval -1 comma 6. And we can go through another video in the future determining how a function is differentiable or not. Again, we will be there soon. So now we have our first two criteria done. So now we have to find out if f of a equals f of b. So let's go ahead and do that. Well, here we're going to say, and you can remember this for your future problems as well, this is a and this is b, and this is here from your closed interval. We can write it in brackets too. So let's go ahead and see if they are equal. So f of a is going to be -1. So we have f of -1. And now we're just going to substitute in -1 for our function right here. So we have -1 squared minus 2 times -1 over -1 plus 2. So pretty simple math here. -1 squared is just 1, right? Minus 2 times -1 is -2. Over -1 plus 2 is 1. So we have 1 minus minus 2, which is just 3. And then over 1 equals 3. So that is our f of a. And we can move this and make it smaller and put it to the side. So that is that. And now we have to figure out if f of b, or in this case f of 6, is equal to 3 as well. So we're going to do that right here. So we have f of 6 equals, I'm going to substitute in again with 6, so we have 6 squared minus 2 times 6 over 6 plus 2. So 6 squared is 36 minus 2 times 6, which is 12, over 6 plus 2, which is 8. 36 minus 12 is just 24 over 8 equals 3. So we can see that f of a does in fact equal f of b. So there's one last thing we have to do. Take the derivative and set it equal to 0 to determine if Rolle's theorem actually does apply. That is the last step we have. So we also know that f of a equals f of b. I can make that the same color really quickly. Okay, so let's go ahead and do this last step and take the derivative. So we have f of x. You can do it in light blue. We have f of x, or f prime of x in this scenario actually. So we're going to do quotient rule here, and I believe I did make a video over quotient rule and product rule. You guys can go ahead and check that out. Well, here we're using quotient rule, so we're going to have the derivative of our numerator, which is 2x minus 2 times our denominator, x plus 2, minus the derivative of our denominator, which is 1, times our numerator, which is x squared minus 2x, all over the denominator squared. So now we're going to set this guy equal to 0. And after everything, you should be left with x squared minus 4 over x plus 2 squared. For a fraction to equal 0, you're essentially just setting the numerator equal to 0. So x squared plus 4x minus 4 is what you should end up, and you're going to equal that to 0, your numerator in specifically, in this scenario. And once you do that, so you're going to have x squared plus 4x minus 4 equal to 0. You guys can ignore this practice problem. I'll move it down. So you can see here we have a quadratic equation, so personally I'm going to use the quadratic formula in order to solve for the zeros. And again, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's go ahead and write that down here. So we have negative b is this term right here. So we have negative 4 plus or minus the square root of b squared. So 4 squared, we can label these real quick. That's a, and that is c. We're essentially just looking at the coefficients of these values. So we have negative 4 plus or minus the square root of b squared, so 4 squared, which is 16, minus 4 times a, that's the coefficient is 1, times c, which the value is negative 4, all over 2 times 1. So simplify the interior of our square root. We have 16 minus 4, so we have 16 minus 4 times negative 4. Negative 4 times 4 is negative 16. So you have 16 minus negative 16, which is essentially 16 plus 16, which equals to 32. So we have the square root of 32 in our parentheses, negative 4 plus or minus out here. So what we're going to do is we're going to divide both terms by 2. So we have negative 4 divided by 2, which is negative 2. So we have negative 2 plus or minus, and if you did this square root of 32 over 2, you should be left with something like the 2 square root of 2 value. And now we have negative 2 plus the 2 square root of 2, and negative 2 minus 2 square root of 2. And now these are technically what we call the c values when we were defining our Rolle's theorem. One number c, okay, at least one number c. So remember, it has to be in the interval, and remember our interval in this question was negative 1, 6. So let's see if they both fit. Well, negative 2 minus a number is going to be less than negative 2. So this doesn't fit, because remember our lowest number is negative 1, and negative 2 is already less than negative 1, and if you're making it more negative, it'll become more negative. So we know that this value right here is not going to be in our answer. So we can mark it in red, that this is not our answer. But let's go ahead and check the second one. So for the second one, we have negative 2 plus 2 square roots of 2. 2 times the square root of 2 is approximately 2.8. And negative 2 plus 2.8 is above negative 1 and less than 6. So this is in our interval, and this is our c value. So our c value is negative 2 plus 2 square roots of 2. And remember, we did both plus and minus, because whenever you take the square root of a value, you look at the plus and the minus. So that's how you do example number 1 in this video. So again, you guys can go scroll back through the video, go through each of the steps, and again, you're just first finding if it's continuous, then finding if it's differentiable. And again, when it's continuous, you're looking at the closed interval, differentiable open interval, that's why parentheses. And then you have to make sure f of a equals f of b. Once it does, or if it does, and you've satisfied all of these, then you're going to go ahead, take the derivative, set the derivative equal to 0. As soon as you set it equal to 0, get the values, make sure those values are in our interval, and that's how you get your c value. We're going to do one more problem really quickly, and the question is asking us that, again, to determine if Rolle's theorem applies. So here we have f of x equals x squared minus 2x times e to the power of x on the closed interval 0, 2. So first what we can do is, again, we're going to determine if it is continuous on this interval. Well, I can't think of any values between 0 and 2 that would make this undefined or not continuous. So we have f is continuous. F is continuous on the, remember it's a closed interval for continuity, so we have 0, 2. Oops. 0, 2. And then we have to determine if it's differentiable. Again, differentiable is just making sure you can take the derivative at any point in this derivative, which you can, and it is continuous, so differentiability is there. So is differentiable. And when you're doing Rolle's theorem, you really don't have to always prove it. You can just state it on the open interval 0, 2. And open is dedicated by parentheses, and closed intervals are shown with brackets. So now let's go ahead and work this out. So we now know it's continuous and differentiable. Remember our third step. Our third step was to determine if f of a equals f of b. Let's go ahead and do that down here. So we're going to substitute in 0 as our a and 2 as our b. So let's go ahead and do that. So we have f of 0 equals 0 squared minus 2 times 0 times e to the power of 0. And so we can see inside our parentheses we have 0, 0 times e to the power of 0, which is e to the power of 0 is just 1, is just 0. So we know f of 0 equals 0. Now let's go ahead and do f of 2. So if we do f of 2, we get 2 squared minus 2 times 2 times e to the power of 2. Well, 2 squared is 4 minus 2 times 2, which is also 4, right? 4 minus 4 is 0. 0 times any number is 0, so we have 0. So we know that f of a does equal f of b because both are equal to 0. So we can write that 2f of a equals f of b. So now we're almost done. Remember, our last step is to really take the derivative, set it equal to 0, and get that c value. Well, let's go ahead and do that right now. So we're going to take the derivative of this equation. We can see that we're multiplying one function by another, and as you guys know, that is a product rule function. So let's go ahead and do that real quickly. So we have f prime of x equals, and remember product rule is just f prime times g plus g prime times f. So we have the derivative of our first one, which is just going to be 2x minus 2 times our original g, or our second function, which is e to the x, plus the derivative of e to the x is just e to the x. As you guys know, I will be making a video on the derivative rules soon, and multiply that by our original f of x equation, which is just x squared minus 2x. And in this scenario, f prime is not referring to the whole equation, it's just referring to this and this. You can call it whatever you want. I'm just giving you the basic equation. The basic equation is h of x equals. So this is a good practice for your product rule. Let's go ahead and simplify this. And after simplifying, multiplying, and setting it equal to 0, you should get a value of x equals the square root of 2. And that is actually our c value as well, because square root of 2 falls within our interval of 0, 2. I really hope this video helped. If you guys believe it did, please consider like and subscribe, share with your friends, and help us get to our goal of 200 subscribers. Again, if you guys have any more questions, you can comment, DM on Instagram. Instagram is linked in the description below. If you guys have any more video suggestions, again, always feel free to comment or DM. Thank you guys.